Welcome to classes on polymers, and it is the topic which was missed out and deleted, I think, in the higher secondary second year classes, but it is very much important for entrance, any entrance, also in the CUT exam point of view. That's why understanding the importance of the class today, I am going to start polymers, and which is a very interesting class. Minutely follow the class. Before starting the class, let me first define and let me write some of the important things which is known to you. And what are polymers? In short, I am telling you, polymers are macromolecules or the polymolar high molecular mass, high but high molecular mass macromolecules consist of repeated structural units derived from monomers. Now, what are monomers? I will explain it later on. Monomers, these are the units which repeated give you the polymers, and this gives you macromolecules, high molecular macromolecules, mass, high molecular mass macromolecules. These are bigger molecules with huge molecular mass, hence it comes from or derives from monomers. The monomers, the units or the substructural unit which repeated many times to give you polymers, and that repeated monomers give you polymers, and the unit which repeated to give you polymer is called monomer. The unit which repeated to give you polymer is called monomer. Say n types of monomers are there. On polymerization, it gives you polymer, and that polymer is of repeated a like this. That is, it is nothing but an. So this is the unit monomers, and that monomer is n times, and that n times is get attached repeated a this to the power n. This is called polymer, and the unit which is repeated many a times to give polymer is called monomer. This is called monomer. So before starting this one, let me just make you familiar with some of the things which you already know. So let me tell you some of the important names of the molecules which will very often come in need in polymer chemistry, and which one will be your monomers. So before starting the class, before the starting the main unit of this class, you first in short try to know what is this. CH2CH is called ethene, and it is, this group is vinyl, and this is cyanide. It is vinyl cyanide, but here it is named as acrylonitrile, means this group is nitrile groups. And CH2C, it is vinyl chloride. This group is vinyl, and this is chloride, vinyl chloride. And this is 2-methyl but 1,3-diene, 2-methyl but 1,3-diene. Each and everyone know, but its special name here is isoprene. This is isoprene. You must know it. It is the monomer of natural rubber, so that's why I am taking it here. This is 2-methyl but 1,3-diene, means it is isoprene. And this is chloropene. And again, this will come in need. It is the monomer of natural rubber which gives you neoprene. Sorry, and artificial rubber. Artificial rubber we makes is synthetic rubber, means synthetic rubber, chloroprene. Very often isoprene and chloroprenes are the monomer of which natural rubber, artificial rubber, it is asked in the exam. That's why I am giving you the name of this one. Now this one is diamine, and this is hexamethylene. So hexamethylene diamine, hexamethylene diamine, and this is tetramethylene dioic acid, and its name is adipic acid. And this is important because of the fact that these two will come in it. These two are the monomers of nylon 66. You will come later on. So you should know the name hexamethylanidiamine and adipic acid. This is glycine, and this is caproic acid. These two are monomers of nylon 2 and nylon 6 biodegradable polymers. This is ethylene glycol, and this is melamine. This will come in neat in preparation melamine formaldehyde polymer, and this is very important. Once again is caprolactam, and this is monomer of nylon 6. Very often comes in the state exam, NCERT exam, and so also in entrance exam. So these are the some important monomers which are going to be used in discussing the polymer structure. So let me come to the main part of polymer chemistry. Here, polymer, there are three types of polymer. One is natural, other is semi-synthetic, and next one is synthetic. So three types of polymer will deal with the three types of polymer. One is natural polymer, other is synthetic, semi-synthetic polymer, other is synthetic polymer. Natural polymer name implies that this will come from plant or animal. So these are cellulose, protein, starch, resin, rubber, and semi-synthetic cellulose acetate. It is also known as rayon, and synthetic alloys. You assume one example, nylon 66. Bit by bit, I will explain each one in a explicit manner. Type of reactions. So polymer reactions are in general two types of. Here in your course it is two types. One is addition polymerization and other is condensation polymerization. So in addition polymerization, a lot of things are there. You might follow. A lots of questions are asked which one of the statement is true, which one is false. So you should know. You follow my lecture, you can understand. There are monomers of same type or different. Monomer may be same type, same one type of monomer will combine, will add up to give you the polymer, or two different type of monomer will combine to give addition polymer. Now, fact is, if the monomer is same type, one type monomer gives you polymer, then it is called homopolymer. Example is ethene, polyethene, and if monomer types are of different, but one is alkene or alkadiene or derivative. Say one type of monomer is other is alkene or alkadiene or alkadiene derivative, and if these two combine give you polymer, and that polymer is called copolymer. Very often asked in exam. One example here I am giving. If there is a monomers of alkene type, mind that monomers must be alkene type in addition reaction. It is first criteria. If it is alkene, it is a monomer, single monomer, and if it gives like this, then it is no doubt addition polymer, and it is a type of homopolymer. Means if it is ethene, and if this ethene on polymerization gives you same monomeric unit repeatedly, then this is called polyethene. So polyethene is an example of homopolymer. Now if it is buta 1,3-diene and other is styrene, that is one is alkene, dialkene, and other is any other thing, and if the two compound gives, then this is copolymer. So say ethene or buta 1,3-diene plus styrene will gives you butadiene styrene copolymer, and its name is Bunaes. So Bunaes, in due course of time I will give the structure, is an example of copolymer, and it is addition polymer because one part is alkadiene, alkene part is there. Whenever there is alkene part, it gives you addition polymer, and if the monomer is single alkene, it will give it homopolymer. If the monomer is one alkene or dialkene, other is any other thing, say styrene, then it's give you Bunaes. So if it is butadiene and if it is acrylonitrile, then it is Buna, and I will explain it in separate way. So Bunaes, Bunaen, etc. are again addition polymer, and it gives you addition copolymer comes from addition polymer. Number 3, in addition polymer, the alkene parts get added, get attached, polymerized, dimerized, trimerized, tetramerized. In this way chain length increases. So its another name is chain growth polymer. So another name of addition polymer is chain growth polymer, as its chain by due degrees increases gives you high molecular weight simply by adding and adding in presence of catalyst. So this is all type of the addition polymer, and now the next one is condensation polymer or trifunctional, but there is no mention of alkene. Bifunctional or trifunctional, NH2 NH2, COOH COOH. Am I right? So functional group are different, bifunctional or trifunctional monomers. No question of alkene is there. Hence it is not addition polymer, it is condensation polymer. So in this process there is loss of water, loss of alcohol, loss of HCl, etc. So whenever you get the monomers is bifunctional, trifunctional, and there is possibility of losing of water, alcohol, HCl, etc., then it is nothing but condensation polymer. So number 3 again is very important. In condensation polymer, a lots of steps appears, and each step has individual identity. each and every steps are independent to one another. Each step are independent, and each step has the ability to go further reaction with the functional groups. Am I right? Hence, it is also called step growth polymerization. Step growth polymerization. First one was chain growth polymerization, here step growth polymerization. So these are some simple points or characteristics of condensation polymers. Monomers are bifunctional, trifunctional, loss of water, alcohol, HCl, and each steps are independent. Each steps have again can initiate another reactions, and each and every steps are different. I will explain it during the phenol formaldehyde polymerization, and it is hence it is called step growth polymers. Now, addition polymerization. It is ethene and it repeated in many times, hence it is called polyethene. Under high pressure and temperature in presence of catalyst, when ethene undergo polymerization, it gives polyethene. It is one example of homopolymer because single monomeric unit is alkene and single monomeric unit is alkene. That is same, the same unit is repeating, and it is also an example of homopolymer, and it can also be called as, it is an actual also an example of addition polymer. So a bit earlier I have shown you that it is acrylonitrile. One thing I have forgotten to mention is when there is polymerization process, when there is double bond, this double bond vanishes as a single bond, changes into smooth bond, and if there is double bond at the end of butene, butadiene, 1,3-diene, so 1 and 3 will come to the middle. I will show you. So you follow this one. So this is acrylonitrile, and it is polymerizes. It gives you polyacrylonitrile, and its another name is polyacrylonitrile pen. And it is very often asked what is the monomer of pen. You should know that it is polyacrylonitrile, and its monomer is acrylonitrile. CH2CH is vinyl cyanides, or it is acrylonitrile. In this way, its monomer is also this. So the starting material is monomer, which is going to be repeated many times, is called monomer. Since this two has these monomers. This is vinyl chloride, and when it's polymerizes, again it gives you polyvinyl chloride. It is known to you polyvinyl chlorides, vinyl polyvinyl chlorides. In pipes preparation, in pipes you have used polyvinyl pipes. You know it very well. So these are third type of addition polymers. You know this is styrene. So vinyl benzene, or you may write it like this: CH2 double bond, CH bond, C6H5 phenyl group here, and when it's polymerizes, you will write it like this: single bond will become double bond, will become single bond, and in this way It is polystyrene. So the monomer of polystyrene is styrene. Am I right? Again, the first one was polythene. Polythene are of two types. Low density polythene. This is low density polythene. So what is low density polythene? The preparation I have shown you. This is layered structures, and there is a lot of cross links in between these two. It is linear type polymers. Its density is low. It is also called elastomers, and on releasing the pressure, when you extend it, it comes back, but it takes time. It has low tensile strength. It is inert. It is rigid. So elastomer, rigid, inert, low density, low tensile strength. Am I right? Hence, it has less application in comparison to high density polymer. High density polymer are of same type, but here in this case cross links are more. Due to more cross links, it is elastomers, it is more rigid, and it is tough. It is more tough than this one. It has high density, it has high tensile strength, and when it extended, it rebounds back to its original position with shorter time. Hence, it is in better quality. But one of the important point here, very often asked in the exam, is that there is a catalyst which is called Ziegler-Natta catalyst, which is used in preparation of high density polymer, and it is very often asked. The formula of Ziegler-Natta catalyst is triethyl aluminum plus titanium tetrachloride, and very often asked in entrance exam. So entrance point of view, this is very important. So high density, low density is over. Bunas, though it is addition, but it is copolymer. Copolymer. So but 1,3-butadiene. It is S for styrene. So styrene is CH2 double bond CH C6H5. I have mentioned already the structure of styrene, and this styrene is like this. So when you use peroxide is benzol peroxide or tert-butyl peroxide or acetyl peroxide. Lots of peroxide are used. Benzol peroxide C6H5 C double bond O C double bond O C6H5. This is benzoyl peroxide. Peroxide is there, or you can use tert-butyl peroxide or acetyl peroxide. These are the very commonly used peroxide used in addition reaction. Am I right? So 1,3-buta-1,3-diene plus styrene. It will give you the style of writing. This one is here. You give an arrow CH2 single bond. That double bond at that double bond will come in the middle. Am I right? So you write CH double bond CH single bond CH2, just to have arranged the double bond in this way, and here we will link with this one here. CH2 bond, CH double bond will convert to single bond, and C6H5, again this is single bond. Here there is one H, and this is called actually this is the butadiene styrene copolymer, and its name is Buna S. Am I right? So you may ask in the exam then which are the monomers of Buna S. Answer is butadiene 1,3-diene and styrene. Now again you may ask that Buna S, Buna N. So this is once again CH2 double bond CH bond CH double bond CH2 plus this is N molecule CH2 double bond CH bond Cl. So you know this is acrylonitrile. When acrylonitrile and these two combine in presence of peroxide catalyst, then again this will become CH. These two bond will arrange in this way, in this fashion. So CH bond CH double bond CH bond CH2, and this is CH2, and this bond is single bond CH bond Cl, and this this is called Buna N. So we have more or less completed some of the very important which are mentioned in your book or in the text, the Buna N, Buna S, and all other type of addition, type of reaction. Now we will come to condensation polymer. Once again, these are very important. Polymer chapter is very important and nothing to learn. Simply just to follow the class, you can understand. Condensation polymer, condensation polymerization. So these are different types of condensation polymerization. Number one is polyamide polymerization, polyamide NH2 groups, and polyester polymerization. So out of this, first we will come to the polyamide polymerization. Here we will just take an example of the nylon 66. Nylon 66. Here we will get CH2 halting 6 NH2 plus adipic acid. When you take both are in NN moles, so this is hexamethylene diamine, and this is adipic acid. So I have written COOH in this way, and there is a fact. The fact I am explaining here. NH2 I have written in this way because there is loss of water, question of losing water, and this water very carboxylic groups, OH from carboxylic group and H from NH2 amide, amine. So these two will give you loss of water. So what things remain, you just write. So again this NH2 will react with COOH of other adipic acid, is not it? So here one H will go away like this. So here will be NH. So your answer will be NH bond CH2 halting 6, and there is NH bond, this is water, C double bond may be written in this way, CH2, whatever is written just I am writing. Again this support COOH again will come with this one, from one H and OH will go out. Am I right? OH will go out, and that OH will go out. There will be CO left, and this will be repeated many times, and this is called nylon 6,6 polymer, polyamide polymer, high tensile strength and types of cord, ropes, a lot of things, application. It is very simple. You find it in use. You can know anywhere. Ethylene glycol and terephthalic acid, both are NN units. So I have told you at the very first class, what very first part of this class, terephthalic acid is COOH. Am I right? COOH, COOH in para position of benzene. Two COO group in para position of benzene. Am I right? So this is called terephthalic acid, and this is called ethylene glycol. So from ethylene glycol OH, and from carboxylic acid OH, and from carboxylic acid COO, from COOH OH, water will be loosed out. So what we get here, the same case, OH from H, OH will go out with the COOH groups. From COOH group OH will left out, and from OH groups only H will left out. So here will only one O. So one O, and this is CH2, and here O, and this is C double bond O, and here the same benzene ring, and here OH again will come with COOH H. H from here will go there, so OH will go out, so COO group will remain in position. So this is called dacron, tyrrhine, tyrrhine or dacron, all the same. So tyrrhine or dacron, it has the monomer ethylene glycol and terephthalic acid, and this is again another example of condensation type of polymerization. Glyptal, and it is another type. Here again we will use ethylene glycol, and this will now react with N molecule. I am not giving N molecules, sir. Phthalic acid, not terephthalic, and phthalic acid is here. The COOH groups is side by side in ortho position. Am I right? So if it is ortho position, it is phthalic acid, and this is ethylene glycol. On phthalic acid and ethylene glycol reacts, this again OH from carboxylic and H from this will leave out to give you water. So what we get here is again this one from H will like go, this H, another ethylene glycol will come to here, and H, OH and H, in this way H from OH groups another ethylene glycol, water will lose out. So what we get here is bond O, CH2, CH2, O, C double bond O, bond See the technique of writing here. With this COOH, there is CO group is remaining, and it is getting attached in this way. When this part of CO, another phthalic acid is made to react with ethylene glycol. Again, the same reaction will occur. OH from carboxylic and H from ethylene glycol will go out to lose water, and CO will remain here. OCH2, CH2, OC means ester. It is polyester. Ester group is there. It is polyester polymerization, and COO will remain this in this way, and this is called glyptal. Am I right? This is the another example of condensation polymerization. 9 on 6. This is called caprolactam and it is monomer of nylon 6, not 6,6. 6,6 I have already shown you. Here NH 1, 2, 3, 4, 5, 6, 7. You require to give 7 bond. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Am I right? NH CO NH group should be side by side. Now what's happened here? You see uh, um, uh, here it backs here in this point. So how many carbon you are getting? 1 carbon, 2, 3, 4, 5. Besides this carbon, 5 carbon. So you are getting NH open bond 1, 2, 3. Each carbon has CH2. So you are getting CH2 5 time and CO is open C double bond O and this will be repeated in this way. So this is nothing but nylon 6, very often asked in state and NCERT or India level questions, and it is also important for entrance point of view. It is caprolactam, the nylon 66 is polymer, nylon 6 is polymer, is monomer is caprolactam. Melamine formaldehyde polymerization. So in melamine you write in this way 1. Am I right? Give here N, give here N, 3N is coming, greater than or less than sign N, greater than N, greater than less than N, greater than less than N, give like benzene, alternate single bond, double bond, and wherever there is carbon, you give NH2. So when it is made to react with formaldehyde, HCHO, that may be written as CH2O. So that will give you N, N, N in this way. Here NH2, NH2, here NH2, CH2OH, NH, CH2OH. It is an intermediate which on further reaction it loses water and it gives you a polymer where NH will lose out one H. So here N, N, N. So this is called melamine formaldehyde. It is non-stick crockery. It is used non-stick crockery, monostic wares. A lot of non-stick wares we have used. We always used in our day-to life in kitchen materials. This is melamine formaldehyde polymerizations, where this is called melamine and this is formaldehyde CH2O, and this is intermediate and this is final polymeric product. One in addition polymerization, I have missed one thing. So this is very important. CH2 molecule. Keep it in your mind on polymerization. It will give you CF2 single bond, CF2 bond, and it is tetrafluoroethene, and your answer is Teflon. Teflon, you know the use of Teflon. And the monomer of Teflon is tetrafluoroethene. I have missed out. You please add up in addition polymerization, not in condensation polymerization. So after melamine, the next part of the condensation polymerization is your formaldehyde bakelite. Let me write it, bakelite. Bakelite. So bakelite is phenol formaldehyde polymerization, and everybody of you know the structure of phenol is this and formaldehyde is this. On reaction, or this may react in presence of acid or base, and this gives you sorry, OH CH2O plus when this part hydrolyzed, this linked up in this way, giving you a chain polymerization of like this. And you see, I told in first part of this class, then condensation polymerization, there are the steps, and each steps has the individual existence, and each step has the ability to initiate another reaction. Each state is independent, each step is the independent of other one, hence it is step goes step, hence it is a step, it is not stop and last, it is a step, it is called novalec, and it is a polymerization again of phenol formaldehyde, and it is used in paint. Am I right? So it is one part of phenol from a novalec which is used in phenol formaldehyde polymerization. Now again, when this novalec, this total part is again made to react with I am effacing out the first part, made to react with formaldehyde, a very solid and tricky three-dimensional uh, net structure appears, which is nothing but bakelite. So what we get is like this. So our first part was like this. Am I right? So I have written the same without changing. Am I right? It will go on. Now here this again, you may confuse there. I will show you the technique. The same part, the same layer is the same in this way, and this layer is just up is down. I have written up is down, CH2 is here, OH is here, and CH2 is above. So this is linked in this way. This is cross-link structure, very hard, very strong structure used in electric board, switch, and other non-conducting of electricity materials, and hence it is called bakelite. It is the name of the bakelite is another is thermosetting plastic, because on heating it cannot be remolded, it loses structure, it doesn't regain its structure, it give you some different other things, you can't regain its structure, so hence it is called thermosetting plastic. One plastic is thermos plastic, other is thermosetting plastic. Polyethylene is thermos plastic because if you heat it on temperature, it shrinks and it takes a mold situation, and out of this you can give the different shape. But when the thermosetting plastic, that is bakelite, when it loses its structures, it cannot be remolded, hence it is called thermosetting plastics. So rubber may be natural and may be synthetic. So first of all, we'll talk about natural rubber. Natural rubber, from rubber tree we get is natural rubber, latex, LATEX, latex. When it is mixed with water and with a lot of process, we get natural rubber. So natural rubber comes from isoprene. I have already earlier I have given this name. This is isoprene, and this structure on polymerization give you natural rubber. So how it gets polymers? Before that, there is a technique. You may write the structure, may not write the structures. I am showing you the process. You see, CC double bond, these two bond will be inclined, will be adjusted, that these two bond, double bond will come in mid. Am I right? So you give here CH3 and CH3, and this is CH3 and this is H. Total carbon 1 2 3 4 5 and 1 2 3 4 5. Am I right? So I have written in this way. Then we'll start polymerization. So how it will go? It will go in this way. CH3 bond, CH3 double bond. Take H above, and this is CH3 below. Here you give it CH2. Am I right? And in this CH2, again one unit it keep. From CH3 you write CH2, and here C double bond will remain same, and here below CH3 will remain like this. Here H is above, here H is below, here CH3. Again it will go in this way, it will go in this way, like it is going this way. It is in cis form, it is in cis form. So this is natural rubber, CH2. Again this will link with another CH2 above, one from below, other from CH2 like this. Am I right? CH3 C double bond, it will go on from below to above, from above to below, below to above. This link will be like this. So now what is the utility of this one, and what is the advantage and disadvantage? Let us in a short explain. First of all, it is less elastic, elastomeric effect is less, because it has when it is extended, it cannot come to its original state or shape or structure very quickly. Number one. Number two, it is cannot easily regain shape on releasing stress, on releasing stress. Number two, it absorbs water. Number 3, soluble in nonpolar solvent. Hence, it is seen that it has got less utility in comparison to other type of rubber. So what's happened? This natural rubber is treated with 5% of sulfur to make some cross-link of sulfur between carbon-carbon double bond. Carbon-carbon double bond, am I right? Not so. If two layer of carbon-carbon double bond, between the end of the two carbon, one sulfur enters in this way, and that gives you a cross-link with sulfur, and that makes it smooth tensile, and now this has ability to regain its original structure after releasing the stretch. It has got more strength, physical strength. Hence, uh, this process is called vulcanization. So vulcanization is the process of introducing some cross-linked sulfur, 5% sulfur in the natural rubber to regain its property or physical strength. So next one is synthetic rubber. Synthetic rubber is any vulcanized rubber. Vulcanized rubber. Hence, these are either homopolymer or copolymer. It may be both. Either homopolymer or copolymer. For entrance point of view, they may give you the statement and may ask whether it is true or false. Synthetic polymer is either homopolymer or rubber. One type of synthetic polymer, I told you chloropene. So you write CH2 double bond, CH double bond, CH, CH2 double bond, CH double bond, CH2. It is buta 1,3-diene. So here you put a chlorine. So this is called not isoprene. This is chloropene. This is chloropene. When this chloropene combined, so what's happened? Bond CH2, bond CHCl, bond CH double bond, again single bond, and this double bond will come here in the mid. Am I right? So here you are writing this. Am I right? So CH2 single bond, CH double bond, CH bonds, that double bond will become single bond. It is arranged in middle, and this will be repeated. So actually it is polychloropene, polychloropene, and this is more naturally named as neoprene. And in entrance exam or in a general exams, it is asked neoprene is natural polymer or synthetic polymer. Answer, it is natural polymer, and neoprene is coming from chloropene, and the structure of chloropene is this. It is monomer of neoprene. So neoprene is a polymer, so its monomer is chloropene. Am I right? Sometimes chloropene, isoprene, you will be get confused in exam. Keep it in your degradable polymer. So in biodegradable polymer, uh, These two are again very not least important but very important. At the background of my class, I am giving you some concept on biodegradable polymer. I am not going to write the structure and show you the products. In short, I am giving you 3-hydroxybutanoic acid plus 3-hydroxypentanoic acid. These are the two monomers, out of which we will get polyhydroxybutyrated beta hydroxyvalerate, VALRAT, valerate, PHVB in short form very often comes in entrance exam. PHVB is a type of the biodegradable polymer which arises from 3-hydroxybutanoic acid and 3-hydroxypentanoic acids, and these are biodegradable degraded microorganism when it is placed in open field. Nylon 2 and nylon 6 is another biodegradable polymer which is glycine and NH2CH2COOH and caproic acid is NH2CH2 whole thing 5COOH caproic acid. These two will combine. This will give nylon 2 and nylon 6, and I am not showing with the arrangement, so you can yourself from one H you take one OH, from here you cancels out water, this H you arrange H here. In this way there will be CO, there will be CO. In this way you make, and you get yourself do the same. Hope you have followed the class with utmost interest, and this is the very interesting class. Please subscribe the class to get the another missing class which are missing in the normal classes. So but in CUT or in entrance exam these classes are important. I will take another new class which is not included in the higher secondary final exam. Thanks a lot for watching the class, and don't forget to subscribe the class to get the updates of new class. Thanks.